my Facebook page an hour or two ago. Maybe there'll be some people that trying to catch the streaming from there.
Yeah, sure. So I'll start now with a Russian introduction, a little one, and then we'll follow up in English. Okay?
Трансляция пошла. Я назначаю его
Да, хорошо.
хостом и выхожу.
Хорошо, спасибо большое. Добрый вечер всем зрителям публичной программы летней школы космического искусства, который проходит сейчас в Музее космонавтики в Москве. Меня зовут Наталья Фокс, я куратор этой школы. Также сегодня на встрече с художником Джо Дэвисом с нами мой соорганизатор этой школы Питер Керн, который является ее фасилитатором. И у нас сегодня очень особенное событие, поскольку я абсолютно рада и благодарна тому, что Джо согласился поучаствовать в публичной программе нашей школы. Он является очень уникальным автором и одним из первопроходцев в области междисциплинарного искусства. Наверняка вы все знакомы с его биографией, если вы пришли сюда предварительно, прочитав какие-то материалы о Джо Дэвисе. Если же нет, то я хотела бы сказать, что он стал первым художником, который приобрел совершенно особенный статус в научных лабораториях MIT в США, и, собственно, где он до сих пор преподает и работает с рядом экспериментальных проектов. Его художественные высказывания, они, конечно же, повлияли на жизнь, карьеру и на взгляды большого количества художников, которые называют себя медиахудожниками, междисциплинарными художниками. И сейчас Джо проходит такой особенный период в своей жизни, когда мы считаем особенно важным поддержать его возможностью такого как бы дополнительного публичного высказывания вместе с нами. И я рада, что это происходит именно в формате летней школы космического искусства. Дальше о проектах больше расскажет своих сам Джо. Я призываю вас очень внимательно слушать и стараться поймать вдохновение. So, Joe, I've been just giving some introduction about you and your art practice and how important and influential your artistic message is and was for so many professionals and artists in art and science, in art and technology. And thank you very much for that, because this influence is covering several generations already, I would say. And I'm very thankful that you are part of this public program now with us. I just said that I really want the other people to be very attentive to what you say and get inspired by this as much as those people who follow your art already became inspired in the past. So to try to make it flowing from one mind to another. Yeah, so let's start maybe. Thank you very much for giving this talk.
Thank you for the kind words. So I should start now, correct?
Yeah.
So how many people?
Let me check, Peter.
I think all of our people are watching. Some of there counts in two places, so it might be hard to say. We have at least a couple dozen coming in. Let's see if more show up.
Okay, great. So I have a talk that's about a swan song. It's funny. This could be a swan song. So over the years, the search for extraterrestrial intelligence has had profound impacts on my art and my thinking. The whole concept of extraterrestrial communications evokes an underlying paradox that Aristotle considered the most important element of human tragedy. That first, we have to reveal ourselves to ourselves before we can reveal ourselves to anyone else. Efforts to contact extraterrestrial intelligence inevitably call for concise answers to fundamental philosophical questions about who we are and what we know. Most of us recognize that human activities on our own planet have precipitated global environmental changes and the extinctions of numerous species. What's more, almost every part of the human race has exterminated some other part of the human race since before recorded history. I'm fooling with two screens here, so please excuse me. Meanwhile, messages transmitted to other stars have nevertheless tended to imply that Homo sapiens is a friendly, peace-loving species with rational scientific attitudes and family values. While SETI messages include purported universal mathematics and audio frequency content suitable for the human sensorium, any extraterrestrial sentience will have evolved in a perceptual, social, and philosophical reality that would be wildly unlikely to be compatible with our own. We're genetically far more similar with, say, tomatoes than with any conceivable alien species. And yet, so far, at least, the tomatoes refuse to speak with us. The least ambiguous parts of our most serious messages for extraterrestrials are actually the messages they contain for human beings themselves. Over the past 3.5 decades, I've carried out several projects centered on ideas about extraterrestrial communications that have in turn given rise to new scientific techniques and inspired new forms of artistic practice. Microvenus was a proof of concept model for biological interstellar message carriers, where huge numbers of biological agents with robust archives could be transmitted across vast astronomical distances in enormous periods of time. But an even newer form of interstellar transmission now falls just within the realm of possibility. This would be an interstellar message created explicitly for human beings rather than for aliens, a swan song with precise reports about the human condition. That might be used to break the wheel of time. But to properly explain all of this, I'm going to have to back up a bit. In March 1975, Wisconsin Senator William Proxmire sent out his first press release identifying wasteful government spending. He called these monthly bulletins, quote, Golden Fleece Awards, and they became a popular feature of his Senate tenure. In 1978, Proxmire awarded the National Aeronautics and Space Administration a Golden Fleece Award for looking for aliens, for wasting money. Fleece, by the way, is a word for the woolen coat of a domestic sheep or a long-haired goat, especially after being sheared. But the American idiom to fleece someone means to use trickery or fraudulent means to take unreasonable financial advantage of another person. So NASA got one of his Golden Fleece Awards for never finding any little green men or flying saucers and spending millions of dollars. Federal funding for experiments involved with the search for extraterrestrial intelligence was promptly discontinued. Private donors continued to fund SETI research to some extent, but the level of support from individuals and private foundations have not been able to compensate for the loss of government support. Meanwhile, some scientists conveniently suggested that sending messages into space might not have been such a good idea after all. In keeping with the SETI funding moratorium, a kind of SETI phobia set in. SETI, search for extraterrestrial intelligence. Many SETI scientists don't fear interstellar warfare, but instead fear for their personal and professional security. Could their organizations handle the public backlash if they decided to transmit? The truth is that many SETI scientists don't actually fear interstellar warfare. They do perhaps fear for their personal and professional security. Oops. In 1897, H.G. Wells published his science fiction classic, The War of the Worlds, in which Earth was invaded by squiggly Martians fleeing their arid, dying world. Besides being scientifically plausible in terms of its times, Wells' novel had a political message. He was an opponent of British colonialism, and he wanted his countrymen to imagine what imperialism was like from the other side. Tales of alien invasion have ever since been a staple of science fiction. And some model for how extraterrestrials might treat humanity. Physicist Stephen Hawking compared prospective contact with advanced extraterrestrials with the disastrous initial contacts between European conquistadors and Native American civilizations. Like many conquering armies of the past, conquistadors killed the indigenous males and took all of their women. This is sort of confirmed by DNA evidence. And so there's an obvious conclusion. I wonder if I can do this. Let's see. Well, Mars needs women, put it that way. So, we have to watch out for astroxenophobia. Richard Carrigan, a particle physicist at the US Fermi National Accelerator Laboratory, nicknamed Fermi Lab in Illinois, went so far as to suggest that even passive monitoring of extraterrestrial signals could render our own civilizations vulnerable to extraterrestrial computer viruses. So watch out. This was my trick. So all Earth-based interstellar radio transmissions are constrained by conditions of atmospheric opacity. That is, how transparent the is to the wavelength of the transmitted signal. In addition, there's an overwhelming background of frequencies naturally produced by the sun, and only a handful of radar transmitters on Earth are actually sufficiently powerful to send messages to other stars. In 1974, astronomer Frank Drake transmitted a powerful radar signal around 1 million watts from Arecibo Observatory in Puerto Rico that could outshine the sun at frequencies between 1 and 10 gigahertz. These are radio frequencies that transmit best through atmosphere. And at a relatively modest 1 million watts, the signal could be seen to be brighter than expected emission in that part of the spectra of any G-type star like our sun. With the exception of Poetica Vaginale, which was transmitted from Haystack Observatory in Massachusetts in the mid-80s, thanks to William Proxmire, for more than 35 years, no one would transmit radar signals into space powerful enough to be detected from the vicinity of another star. As of July 2020, there were 4,197 confirmed exoplanets in more than 2,500 star systems. Estimated 20% of these are so-called Earth-like planets. Yet even before the discovery of thousands of Kepler worlds, scientists predicted widespread existence of technologically advanced extraterrestrials. In the early 1960s, Frank Drake concluded that there are probably between 1,000 and 1 million civilizations in the Milky Way galaxy. He put out his what is called the Drake equation. It's actually not an equation, it's a formula. But 4 of the parameters are not known and very difficult to estimate, and given values for several of these factors are highly conjectural. Associated uncertainties are so large that the Drake formula can't be used to draw reliable conclusions. During a legendary lunchtime conversation at Los Alamos National Laboratory in 1950, physicist Enrico Fermi is supposed to have posited his famous Fermi Paradox, which is that if so many space-traveling aliens exist, they could have already, or they would have already spread through the galaxy, colonizing every habitable world, including our own. So they should be here, but they aren't. That's the paradox. Later, Russian astronomer Alexander Zaitsev proposed yet another SETI paradox. He suggested that while on the one hand, we search the cosmos for technologically advanced intelligence sufficiently like our own that we have some chance to successfully interpret incoming messages, but on the other hand, we're also searching for intelligence significantly unlike our own. We search for intelligence on other stars that actually transmit interstellar messages. At a ceremony to mark the remodeling of Arecibo radio telescope on 18 November 1974, Frank Drake beamed a radar signal into space that was one of the last serious attempts made by human beings to transmit radio signals to other stars. This is Frank Drake's coder. Photograph I made, I actually found the device at Arecibo. It's a device that interfaces with the radar transmission apparatus, enabling radar output to be interrupted at precise intervals, which in turn allowed Drake to transmit a precise sequence of 1,679 ons and offs. Drake suggested that these would be seen as zeros and ones, analogous to a numerical binary sequence. So what does this mean? This is his zeros and ones. So if you're a radio astronomer, mathematician, alien from Cleveland, you would know that a prime number can only be divided by 1 or itself, and that it cannot be factored any further. Drake assumed that you would also know that every other whole number can be broken down into prime number factors. All extraterrestrial mathematicians know this, right? Any composite number can be split up into a product of prime factors, primes which multiply to give the original number. Determining the prime factors of a number is an example of a problem frequently used to ensure cryptographic security in encryption systems. This problem is believed to require something called super polynomial time in the number of digits, meaning it's relatively easy to construct a problem that would take longer than the known age of the universe to solve on current computers using current algorithms. So alien mathematicians would know that 1,679 characters have 2 prime factors, and so could be rastered into a rectangular array suggested by the prime factors 23 and 73. We have one of several compilations, right to left, left to right, bottom to top, top to bottom. Only one iteration contains the intended graphic, and with another great leap of faith, the intended information can be interpreted. Another problem, mathematics may not be such a universal concept after all. French neuroscientist Jean-Pierre Changeux suggests that mathematical axioms are expressions of cognitive facilities, which themselves are a function of certain facilities connected with human language. Mathematicians and philosophers have never been able to agree about what mathematics is in the first place. Thus far, only Homo sapiens and closely related primates have exhibited any indication of mathematical comprehension whatsoever. My reiteration of astronomer Frank Drake's 1679-bit transmission from Arecibo radar in the form of 1679 generic glass bottles in partition racks. Empty bottles represent the binary character 0, and water-filled bottles represented the binary character 1. These 1,679 bottles contain Drake's so-called universal message for extraterrestrial intelligence. I installed this at MIT's Hayden Library, science library in the 1980s, and all the information where in the library, all the information you needed to decode the message existed, and all the information the message referred to existed, and supposedly better than average terrestrial intelligence at MIT could be found there. Still, the reaction to the exhibition was primarily devoted to whether or not the exhibition was art. Nobody decoded the message. In addition to messages encoded as radar signals, some interstellar messages have been sent out on board spacecraft. Pioneer 10 and 11 spacecraft in 1972 and 1973 were launched with trajectories that would ultimately take them beyond the local solar system. Pioneer carried a message plaque engraved with images by Linda Saltzman Sagan. The images engraved into the Pioneer plaque were incomplete representations of human anatomy. We had male genitalia, but not female genitalia. We sent pictures of a man and Barbie doll into space to communicate with aliens. These are the Voyager plaques. In 1977, Voyager 1 and 2 probes were launched into trajectories that would ultimately take them to interstellar space also. These spacecraft carried message materials intended for extraterrestrials. Both the Pioneer and Voyager messages contained censored images of human anatomy, either no nude human images at all, as in the case of Voyager, or in the case of Pioneer, nude human images devoid of external genitalia. The Voyager plaque and record indicated that aliens aren't entitled to know what we look like. I mean, we can assume. Here we have Voyager. Meanwhile, we're mystified by numerous reports of aliens abducting human beings to experiment with their sex organs. I mean, you know, they got to be curious. So, in 1986, I engaged in a project called Poetica Vaginale, in which I transmitted vaginal contractions into space to communicate with aliens. This is the vaginal detector. There was 3 forms of signal: a binary signal, which we produced with an ancient 1980s analog to digital converter, and there was an analog signal, in which the 30 hertz center frequency of the radar pulses were modulated, phase modulated with the analog signal. And this, the signals contain not only voluntary and involuntary vaginal contractions, but also voice, respiration, heartbeat, and other autonomic audio frequency human physiological signals, so that in fact, more information about human beings were contained in this transmission than all other SETI messages. The third form of the signal were harmonics generated by MIT Electronic Music Studio software, collaborating with Todd Mackover's grad students. We generated harmonics of the vaginal contractions until they matched the frequency of one of the 40-something sounds of English speech, which we call phonemes, 44 English phonemes, which were bitmapped by the late Professor Tanya Reinhardt. She was a student of Noam Chomsky and a professor of linguistics and literary theory at Tel Aviv University, so Poetica Vaginale had a kind of Israeli accent. We used a phonetic alphabet, a linguistics phonetic alphabet called Unifon, which you couldn't confuse the G of engine and the J in Joe. And anyway, this is what we got. Let me see if I can run this for you. It's not letting me. Should be a way. This is a video. Well, take my word for it. It was real time. I think I had to transfer my PowerPoint slides, which included some video, to JPEGs and PDFs and stuff to do this screen sharing. And so I lost the video capability, and I'd have to interrupt, take the screen down, go find it and run it. I mean, if you want some of these videos later, I can show them to you. But there were lessons learned from Poetica Vaginale, the characteristics of interstellar radio propagation, and the economics of signaling show that such a beacon would need to operate on vast timescales and is not an efficient way to send an interstellar signal. In addition to problems of atmospheric opacity and overwhelming background of solar emissions, there are other fundamental problems with radio carriers for interstellar communications. These include divergence, the inverse square law. Radio waves are photons, and they're subject to the same inverse square law. An object twice the distance from the source will receive a quarter of the amount of illumination. The receiver would have to be lined with center of the transmitted beam in order to detect it. And the Drake's transmission was only 3 minutes, and it was a single transmission in a single direction. But there are an estimated 400 billion stars in the Milky Way, and the message would only be received by one of them in exactly the right 3 minutes, many thousands of years from now. Although Frank Drake is an astronomer, he failed to account for the proper motion of stars. Over the course of centuries, stars appear to maintain nearly fixed positions with respect to each other, so that they form the same constellations over historical time. Familiar constellations like the Big Dipper, Ursa Major, or Crux, for instance, look nearly the same now as they did hundreds of years ago. However, precise long-term observations show that the constellations change shape, albeit very slowly, and that each star has an independent motion. This motion is caused by the movement of stars relative to the sun and the solar system. The sun travels in a nearly circular orbit, the solar circle, about the center of the Milky Way, at a speed of around 220 kilometers per second, at a radius of 8 plus or minus 65 kiloparsecs from the center, which can now be taken as the rate of rotation of the Milky Way itself at this radius. The Galactic Year, also known as the cosmic year, is the duration of time required for the sun to orbit around the center of the Milky Way. Estimates of the length of one orbit range from 225 to 250 million terrestrial years. So, Drake pointed his message at the constellation Hercules, which is 25,000 light years away, but in 25,000 light years, the stars move away from the signal. In America, we have a children's game called Pin the Tail on the Donkey. You have a donkey tail and you're blindfolded and you try to pin it where the tail goes on the donkey. It's sort of like playing that with astronomy. So, problems with radar include huge distances, that even the speed of light is a slow boat over astronomical distances. Homo sapiens appeared roughly 100,000 years ago, Homo sapiens sapiens, approximate time of divergence from the common ancestor of all modern human populations was about 200,000 years ago. So if mitochondrial Eve, who was estimated to have been about 200,000 years old, had all the equipment and the right power, et cetera, to transmit a signal to the other side of our own galaxy, and it was immediately received and responded to, why the message might not even be back yet, and meanwhile, Eve evolves into a different species. So even if Frank Drake's reasonably local SETI transmission, 25,000 light years, ultimately proves to be successful, we're going to be waiting in the chapel with fresh flowers for the spouse for 50,000 years, nude, descending and descending and descending the staircase. So problems associated with messages attached to spacecraft are much worse. While these are among the fastest ballistic objects ever created by human beings, they will not reach the planetary environment of another star for at least 1 billion years, which is as far ahead as anyone can predict. So there, as I see it, 3 basic problems with all extraterrestrial transmissions, that all extraterrestrial intelligence, messages for extraterrestrial intelligence have in common. And the first of these is robustness, the ability to survive extremes of space environment, temperature, radiation, vacuum. Longevity, is the second, the ability to remain intact for periods of what we consider to be geologic time. And abundance, hundreds of millions of copies for hundreds of billions of possible recipients. These problems, bacteria, especially sporulating bacteria, answer these very well. So back in the early 1980s, I was sitting in a bar room with my my friend and future collaborator, Dana Boyd, and we calculated how many bacterial spores or how many bacteria could fit into a pint glass of Guinness. So we figured all this out, and we had about 1 million spores per star system in the Milky Way, which is actually kind of a small number, but a good number nevertheless, and it inspired Microvenus. Like Poetic Rationale, Microvenus was created in part to respond to arbitrary censorship of images depicting human anatomy and messages human beings have sent to aliens. We used Drake's prime number coding, prime number raster, and converted this icon into a 28 mer, actually an 18 mer and a 10 mer decoding clue that I'll spare you for now. And widely recognized as this work of art to utilize techniques of molecular biology, the first bioart. Critics have long since been concerned with what I call issues of transanimation. That's power over those qualities of vitality and function that distinguish life and death. We have Moses and Aaron throwing down their rods in Pharaoh's court, which turn into serpents. There's stories of Ibis and Medusa, Daphne and Syrinx, and in the New World, Xalotl and Quetzalcoatl and many others. One of my favorites is the story of the sculptor king, the classical myth of Pygmalion in Galatia. Pygmalion was a king and a sculptor in ancient Greece who carved an exquisite marble statue of a woman, that's Galatia. And the king felt that this statue was so beautiful, he fell in love with his sculpture, and the goddess Aphrodite took pity on Pygmalion and brought his marble statue to life. Classical transanimation. So in addition to these poetic motivations, Microvenus was created to represent a possible technical solution for problems associated with all attempts to use spacecraft and radar transmissions for extraterrestrial, for interstellar communications. Microvenus explored the notion that biology could play an important role in sending astronomical numbers of directed messages across hundreds of thousands of light years in correspondingly enormous periods of time. Microvenus was the first genetically engineered work of art and the first use of bacteria to model biological carriers of interstellar messages. The data encoded into Microvenus bacteria consisted of a simple line graphic. Later projects addressed the production of more complicated data, including text and high-resolution digital picture data. The first encoding of text into DNA was the Riddle of Life, my Riddle of Life project in 1995, reiterating an important episode in the history of science. Riddle of Life encoded the English language sentence, "I am the riddle of life. Know me and you will know yourself." 56 characters, 44 letters, and 12 space characters in 174 DNA bases. We'll return to this a little later. Here's the I sequenced the riddle of life at Professor Burkhard Wittig's lab at Free University in Berlin. And I'll tell the story later on. First high-resolution digital image encoded into DNA was the Milky Way DNA, encoding an image captured by NASA's Cosmic Background Explorer, nicknamed COBE, into the physical minutiae of DNA molecules. Milky Way DNA juxtaposed these vast differences in scale. The COBE images were the first images human beings were able to capture of the galactic core of the Milky Way, enabling the most complete maps ever to be constructed of the galaxy itself. But as the body of information to be encoded into DNA grew larger, new kinds of problems appeared. Different organisms prefer different DNA triplets to make protein, to make amino acids and protein. Some of the triplets are pathological, astronomically unlikely, but possible. Useless DNA gets modified or deleted. Large amounts of DNA cannot be directly inserted into the DNA of living organisms without being specially coded to not only keep parity with desired input information, but also to be sufficiently biochemically and biologically friendly to successfully coexist with the host organism. It's kind of like writing with two hands, writing two different messages with two hands at the same time. So to solve these problems, I came up with something I call DNA supercode, which used the genetic code as a base 20 number system. And it allowed me to include information that let me remove special restriction cut and paste sites that let me remove any mistakes, because in those days, DNA synthesis was not quite as efficient as it is these days, and I had to sort of anticipate the possibility of an error, so I'd be able to open up the sequence like a file drawer, fix the mistake, and close the file drawer. More recently, one of my most recent, probably most elegant projects has been concerned with encoding three-dimensional information into DNA. I decided to explore just how efficiently a three-dimensional object could be encoded as a 2D pattern, complete with folding instructions. This is the first 3DNA project and involved encoding an origami crease pattern of a double helix into bacterial DNA. My colleagues in India and I had a eureka moment, and we formulated an extremely efficient vector calculus encoding of the double helix crease pattern. The entire pattern, complete with folding instructions, can be expressed in 94 bits, which translated into just 48 DNA bases, less than twice the size of microvenus. You guys have to excuse me for just a second, please. I have an urgent issue having to do with my physical condition, but I'll be right back. Please stand by.
Yeah, thanks everybody, and thanks to Joe. For those of you who didn't see that I posted this on the YouTube link, we still welcome questions. So we'll have a few minutes with Joe at the conclusion of his talk. So please don't be shy. Anything that you'd like to ask him about from this presentation or other issues you want to raise, go ahead and post those to the YouTube video, which is on the Museum of Cosmonautics YouTube channel. And I'm watching there, and I'll make sure that we answer Joe. We should also say, for those of you who don't know, that this is he's back. So I don't have to stall anymore, which is great.
That's great.
Yeah, thanks, Joe.
So this is Halobacterium salinarum, Heretofore, all the information keeping in DNA in living organisms was done with E. coli, and no one had ever tried to use what's called an extremophile. Halobacterium salinarum is amazingly resilient. It's already known to be particularly robust. It's extremely radiation resistant. Adrian Kish, a member of research group studying this organism at the University of Maryland, said, quote, "We have completely fragmented their DNA. I mean, we've completely destroyed it by bombarding it with radiation, and they can reassemble their entire chromosome and put it back into working order within several hours." In one report, Halobacterium salinarum was able to withstand exposures of 5 kilograms of gamma radiation, which is a huge dose. They can resist oxidative stress, thermal extremes, desiccation, persisting in environments characterized by extreme aridity, routine exposure to high ultraviolet, and they've been shown to survive high vacuum, microgravity, radiation, and temperatures of the space environment in several experiments, these several US experiments and European and Russian experiments. In some of my own experiments, I've been using a poison gas, a nasty poison gas called ethylene oxide, to sterilize external surfaces of salt crystals in other experiments. And for this, I used a facility at the V's Institute in Boston, and Halobacterium could not be killed with 12, 24, 36-hour exposures of high pressure ethylene oxide. This is definitely the thing that couldn't die. So I found stuff growing everywhere. They say that Himalayan salts gets its color from minerals like iron, but I beg to differ. I found these organisms growing embedded in the salts. They're sort of like entombed there in what's called cryptobiotic stasis. It turns out that many of these cultures bear considerable phenotypic and genotypic resemblance to Halobacterium salinarum. I was astounded to discover that while I was culturing, that the organisms I was culturing were from a 250 million year old formation. The Himalayan salt deposits were formed at the end of the Paleozoic era, so at the Permian-Triassic boundary, 250 million years ago. Later, I found organisms as old as 485 million years. These are organisms I found in Ordovician salts. So not only do Halobacterium and its close relatives survive all of these extremes, they've also survived the great extinction events over hundreds of millions of years. The legendary philosopher's stone was not only dear to alchemists and sorcerers because it could be used to transmute base elements into gold, but also because it was reputed to hold the secrets of everlasting life. And I think I may have found one, and it's salt. So consider this. The trajectory of message-bearing Pioneer 10 probe is expected to take it in the general direction of the star Aldebaran, currently located at a distance of about 68 light years. If Pioneer 10 trajectory was targeted on Aldebaran, which it is not, and if Aldebaran had zero relative velocity with us, which it does not, it would require more than 2 million years for the spacecraft to reach it, even though Pioneer 10 is one of the fastest ballistic objects ever created by human beings. Currently at a distance of 100 astronomical units and traveling outward at about 2.54 astronomical units per year, Pioneer 10 spacecraft is approximately 271,000 astro-units from Proxima Centauri, the nearest star. If Pioneer 10 was targeted on Proxima, which it is not, it would not arrive for about 106,693 years. For context, Homo sapiens has existed as a species separate from other hominids for a shorter period of time than that, as I mentioned, for only about 100,000 years. We don't know how many unique star systems, all at a distance greater than this, we would need to reach a habitable planet where life had developed at the moment that our spacecraft arrived, much less life that had the capacity to intercept and understand any message that we send. Thus, our chances of communicating with another intelligent species somewhere else in the universe are slim to none. On the other hand, Earth will likely outlast humanity and remain habitable to something DNA-based that is not us. If we leave messages in DNA that will outlast us, we may communicate with future beings right here on Earth. So about a year ago, last September, I was invited to participate in the immortality-themed Ural Biennale with Ippolit Markelov, my collaborator. And we put together a project about this guy, Kashe the Deathless. He's said to be deathless because I don't have to tell you, because he's supposed to have magically hid his dark soul in the tip of a needle, which he put in an egg, which he kept inside a duck, inside a rabbit, and so on, which he kept in a trunk, buried under a tree, on an island in the middle of the ocean, a disappearing island. So I created a 2D folding pattern for a 3D needle and coded it, co-opting some of the DNA supercode strategy. I spent 4 days collaborating with mathematician Mason Diamante to convert that pattern into concise code at MIT. We also coded an egg, and which together amounted to, oops, that's the egg. That's Mason Diamante. That's the egg. And this is the sequence, about 930 bases of DNA. And this is the first Halobacterium information-keeping archaea ever created. Since messages we can leave in this way may by far outlast the lifetime of the human species, we may start to think about what bequests our species as a whole might leave for a far deeper future. This has been a kind of proof of concept project to demonstrate a method we can use to send the legacy of culture and civilization. My phone keeps dinging, I'm sorry, can't stop it. Yes, a proof of concept project to demonstrate a method we can use to send the legacy of culture and civilization into the far future using signs and symbols of a system of knowledge much older than human history. This may indeed be how we can leave our mark in the sands of time. So while we were at it, coding three-dimensional figures, and to emphasize the difference between our method for holding spatial information in DNA and the earlier so-called DNA origami, we coded spatial data for a hypercube, a four-dimensional object, into a DNA molecule with 224 bases, and have been separately but simultaneously putting this fragment into a second example, which is already done, of DNA data storage in Halobacterium salinarum. While DNA origami techniques cannot be used to hold more than 3 spatial dimensions, our method can hold any number of spatial dimensions. This is also a movie. This is a reflection of this is a 3D shadow of a 4-dimensional object, but I can't show you the movie because this is the JPEG. This is the sequence. And this is the genetic code. This is nature's own DNA programming language. And this is another way of looking at it, my own. On the left is something I call DNA supercode. There are 20 amino acids in the genetic code. And so, oops, so here's the genetic codes. The 20 amino acids are in the right-hand side of the columns with their 3-letter abbreviations. And the 3 base codons are next to them, situated next to them. So I've given the redundant codons binary number values, and any protein is a specific sequence of amino acids, which even for a relatively small protein, you can make astronomical numbers of sequences that with these redundant codons that equal the same protein. So that means that you can write any number underneath the gene without changing the output of the gene or increasing its length. And later I realized that DNA actually has any DNA molecule that's 3 bases or larger can be characterized by 3 unique numbers. One is the base 20 number of the amino acid, in this case proline, the number of the DNA itself, where C equals 0, 0, T equals 0, 1, A equals 1, 0, and G equals 1, 1. And the third number is the number of the redundant codon, which I gave binary values based on the molecular weights of respective codons. And what this means is that each DNA molecule has 3 pages of information, 3 useful pages of information. And so far as I know, nature uses only 2 of them. This system, which I'll call DNA manifolds, makes it at least theoretically possible to contain many layers of information within a given gene or group of genes without increasing the length of those genes or altering translated proteins. And I've recently used this technique because of a story this guy told me. This is Yasser Shadley. He lives in El Cerrito, California. He's from Morocco, and he's a Sufi master. And I often sit around when I'm in California, meet the guy and drink tea, and we talk about secrets of the universe and divinity and so forth. And at one point, he told me a story about how to make angels. All you have to do is repeat a certain phrase in Arabic and you get an angel. And it does like the prayer flags. It doesn't matter whether you speak it or whether you write it or whether you cause it to be printed or whether you get someone to speak it for you. Any way you iterate this phrase, you get an angel. The phrase is Subhanallah, which literally translates to hallelujah. Hallelujah, glory be, simple. That's all you need. It's a tradition that dates back 1,000 years. It's written about in some of the hadiths. And I've been collaborating with Sarah Khan, a young biologist, artist from Pakistan. And together we've coded the Arabic ASCII script into a DNA manifold. And this is the manifold encoding of Subhanallah. It contains 19.5 Subhanallahs in this relatively short sequence. Like the inspired geometry of Islamic art, like the beautiful systems of calligraphy within calligraphy. We think our DNA manifolds are particularly appropriate for this. This is, yes, whoops, this is calligraphy within calligraphy. And this is our Subhanallah manifold DNA that contains 19.5 Subhanallahs in each molecule. So we calculated that we can keep 2.417 billion angels on the 0.75 millimeter pinhead of the average straight pin. This is our paper so far unpublished, but we're like finishing up some small details and we'll post it very soon. So knowledge of molecular biology was in its infancy in the years when investigators first carried out searches for signs of life in distant planetary systems and the first transmissions of messages intended for intelligences on other worlds. Radar is only about 80 years old. Radio astronomy had its beginnings about 86 years ago. And the first modern SETI experiment called Project Ozma was 57 years ago. DNA sequencing was only 40 years old. Note that the Arecibo message contained, if properly decoded, contained a picture that's supposed to represent the DNA helix and the DNA sugars and bases, kind of abbreviated chart of the elements. No gene was sequenced at all until 1972, and routine sequencing of DNA was not possible until 1977, several years after Drake's famous transmission of an encoded image of the DNA helix from Arecibo. It seems likely that SETI involvements with astrobiology may grow to include an examination of large genomic libraries for influences of extraterrestrial origin. The fact that human beings have already created significant data archives in the DNA of living organisms leads directly to the idea that we may engage in the search for corresponding caches of information that may have been intentionally transmitted across great distances in time and space. I can imagine new initiatives drawing together great minds in biology and informatics to create tools needed to foster such a search. So in 2009, I was invited to address the University of Puerto Rico's biology colloquium, and it happened to be the 35th anniversary of Drake's famous transmission. And I had some tricks up my sleeve. Al Wunderlich, Professor Emeritus, former head of painting at the Rhode Island School of Design, and others flew in for an art historian, Danielle Hoffmans, from Netherlands, some from Belgium, Netherlands, Belgium, Flemish. Anyway, and others flew in, and we went to Arecibo, and we walked in cold, insisting that we'd be able to make another transmission for extraterrestrials. And as it turned out, I had to use my iPhone to make trigger the radar. First interstellar phone call. And what we transmitted was the gene for ribulose 1,5-bisphosphate carboxylase oxygenase, or Rubisco for short. It's the most abundant and one of the most ancient proteins on Earth. It's involved in the Calvin cycle that converted Earth's atmosphere from a reducing atmosphere to an oxidizing one, and itself tells a great deal about life on Earth. So we converted the gene for the Rubisco large subunit, and from DNA to base 4, because DNA is base 4, 0, 1, 2, 3, based on molecular weight, and then to binary. And it turns out it's only slightly larger than Arecibo's, than the original Drake message. But unfortunately, Drake's coder was broken. We tracked it down, but it wasn't operative. So there was a race against time to come up with an alternative way to code an analog signal holding this sequence of the Rubisco gene. And the way we did it had to do with the Riddle of Life project. There was a gate at the Temple of Delphi that's reputed to have had the Edict of Apollo inscribed on it, and it said, "Know yourself and you will know the secrets of the gods." And it harkened to the Riddle of Life project, which had to do with Max Delbruck and George W. Beadle and 174 toothpicks that coded for the Riddle of Life. So we coded maxima and minima of 1, 2, 3, 4, I, MD, know yourself, riddle of life. And it's not that we expect any extraterrestrial intelligence to be conversant in English, but the signal nevertheless contained discrete physical maxima punctuated with precise intervals, so that the message holds the sequence of 1, 2, 3, and 4, or if extrapolated as DNA, a corresponding sequence of C, T, A, and G. So this is the audio signal we sent out with the telephone. And we transmitted to 3 nearby stars. I also sent Bahamian musicians while we were setting up. Bahamian musician Andrew Jones' Spirit House song "Run Come See Jerusalem," a song about a sinking ship, while we were selected target stars. So it was the first time in 35 years the successful transmit automatically caused great chaos and concern in the astronomy community. NASA published it in their astrobiology journal. It was reported internationally. And there was this nearly simultaneous furor about whether we should be revealing ourselves to the aliens. Here at the, yeah. This is Doug Baycock. He's one of the proponents of messaging extraterrestrials. And he said, I think that meeting really did crystallize the danger that some of the people in the SETI community perceive, not a danger from extraterrestrials, but a danger in the reputation of the organization, a danger of losing funding. Who in their right mind wants to take on Stephen Hawking? Well, I immediately got a responses from all over the world. One had to do with this guy, Freeman Dyson. In 1960, he popularized the idea that a truly advanced civilization would be more likely to evolve around the dwarf star than around medium-sized stars like the sun, because dwarf stars can persist for billions of years longer. Dyson suggested that in order to soak up the maximum amount of energy from these relatively weak stars, a truly advanced civilization might totally enclose them with gigantic energy collecting astroengineering projects that would span the entire planetary system. And so, excuse me, consequently, I was encouraged to send transmissions to so-called Dyson spheres by targeting astronomical infrared sources that didn't have obvious stellar companions. Another suggestion was very intriguing, submitted to a blog post about the Robusco Stars project. The writer recommended that I transmit messages not to a star, but rather to a black hole. So black holes are persistently mysterious entities that evoke a whole series of inexplicable paradoxes that continue to confuse physicists, and probably very much to the universal delight of artists and philosophers. These include the black hole information loss paradox, the grandfather paradox, the firewall paradox, and many others. The suggestion was that I should send a message not just to any run-of-the-mill black hole, but instead to a rapidly spinning supermassive black hole called a Kerr object. And the reason that I should attempt this kind of transmission is that rapidly spinning black holes appear to smear space-time. One of Einstein's famous thought experiments was about 2 identical clocks, one where one is left on the train and the other, one at the station and the other is placed on the train, and the train goes around, and when it returns to the station, the 2 identical clocks show different times because the clock on the train was in motion while the clock remained at rest at the station. This phenomena of time dilation in relation to motion was actually first described by Dutch physicist Hendrik Lorentz rather than by Einstein. Lorentz published his transformations in 1899 and 1904, whereas Einstein published the basics of his special relativity theory of relativity in 1905. Even though time dilation figures importantly in Einstein's work, he neglected to credit Lorentz in the first edition of Special Theory of Relativity. Nevertheless, it was because Lorentz laid the fundamentals for the work by Einstein that this theory was originally called the Lorentz-Einstein theory. Anyway, clocks on trains. This brought me to several time experiments myself. Inspired by this history and its paradoxical implications, I set up several real world examples of time dilation effects for separate experiments. One experiment in collaboration with the Massachusetts State Police Academy in New Braintree, Mass, and with technical and engineering support provided by MIT's Edgerton Center, we produced images of bullets in two simultaneously but distinctly different time frames. Doc Edgerton took pictures of individual bullets, but never two bullets in two different time frames at the same time. I don't know if you can notice there's a little red streak in front of the lower bullet. That little red streak is still we don't know why it's there. So this is a Mach 2.7 bullet, and this is a sniper round, a Mach 3.1. The images themselves are paradoxes, since individual photographic images display both contemporary objects and simultaneously identical objects that must be existing, even if ever so slightly, in the past. Another red streak. So the fastest objects, the North American X-15 secured a record speed of 4,520 miles an hour, which is still unchallenged as of now. Flight times ranged up to approximately 12 minutes, not much time to accumulate substantial time dilation. In 1976, NASA launched the solar probe Helios 2 to measure the electromagnetic radiation emanating from the sun and to calculate solar magnetic fields. This is probably the fastest spacecraft ever. Its top speed of 157,078 miles an hour, which is still in elliptical orbit around the sun. But it turns out that the fastest reasonably sustainable velocity we can achieve on Earth is in a biology lab in the rotor of an ultracentrifuge. Ultracentrifuges were once ubiquitous in laboratories of molecular biology, and they're still widely used. Some ultracentrifuges can spin around at around Mach 5 times the speed of sound. An object spun at this velocity for 10 days would accumulate a Lorentz transformation time differential of 1/100,000th of a second relative to objects at rest in the meanwhile. So I decided to solve the chicken and the egg problem. I loaded a centrifuge simultaneously with 1.5 grams egg and 1.5 grams chicken, and so they would precede all their chickens and all of their eggs. And I think the Buddha would approve. Problem solved. So Lorentz in 1899, Einstein in 1905. By 1918, Austrian physicists Joseph Lenz and Hans Thierry postulated that these time dilation effects were unfolding in astronomical contexts too, and predicted that the rotation of massive objects like planets would also distort the space-time metric, a phenomena we now call frame dragging. Experiments with spacecraft have confirmed the existence of frame dragging effects around planet-sized objects like the Earth that spin at 1,000 miles an hour or so. This is the Lagios satellite. It's used to measure lens steering effects, frame dragging. There are two of them, and they also happen to contain Carl Sagan's final attempt to send a message to advanced civilizations. It's an aluminum clad, and barely nobody knows about Sagan's message in the Lagios. It's an aluminum clad solid brass 903 pound 2-foot diameter sphere fitted with hundreds of prism reflectors that now circles about 4,000 miles above the Earth. The stability of that orbit is so great that it will not be dragged in by Earth's atmospheric gravitation for an estimated 8.4 million years. This is the message he left, not just for little green men. Sagan intended the message for human beings or their descendants in the far future rather than for extraterrestrials. Etched into two 4x8-inch stainless steel sheets. The plaques graphically and mathematically describe the mission of the spacecraft, when and where it was launched, the position of the continents roughly 268 million years ago and the way they are now, and where scientists anticipate them to drift in the next 8.4 million years, roughly the lifetime of the satellite. So gravitational time dilation is the difference of elapsed time between two events measured by observers situated at varying distances from a gravitational mass. Relative to the Earth's age in billions of years, the Earth's core is effectively 2.5 years younger than the surface. The closer to gravitating mass, the slower the clock. Likewise, considered over the total lifetime of the Earth, 4.6 gigayears, a clock set at the peak of Mount Everest would be about 39 hours ahead of the clock at sea level. A clock further away from a gravitational mass runs faster. Time dilation due to height differences of less than 1 meter have been verified in the laboratory. So this effect is significant enough that the global positioning system's artificial satellites need to have their clocks corrected. And since everything in our universe, including the Earth, seems to be rotating, differences in distance from gravitational mass correspond with different rotational velocities. Orbits of greater angular velocity would result in larger amounts of time dilation. Time dilation effects are assumed to be much more profound around extremely massive objects that rotate at relativistic speeds, like Kerr objects. Owing to space-time distortions depending on mass and direction of rotation, photons could appear to move either faster or slower than light speed as they passed around such an object from the viewpoint of an outside observer. Depending on the observer's perspective, photons such as a radar signal might therefore be detected that would appear to be coming from either the past or the future. These enhanced frame dragging effects are expected to be confirmed within the next few years with precise astrometric measurements of certain stars approaching the supermassive black hole at the center of the Milky Way. A black hole, even the most massive singularity, is thought to be infinitely small and yet powerful enough to choreograph the motions of entire galaxies and swallow billions of suns. The ergosphere is a postulated region around a black hole from which matter cannot, but energy could escape. All forms of matter and energy are thought to be consumed at the event horizon or the inner horizon of the black hole, but unlike the fate of particles of matter, an electromagnetic wave such as radar that transited the Schwarzschild radius or ergosphere of a black hole would be stretched but not destroyed. Thus, any signal to be transmitted to the vicinity of a black hole would comprise a signal of the shortest possible initial wavelength. Likewise, the data content of any such signal may be highly compressed. Effects involving photons and electromagnetic waves are not the only strange temporal effects thought to be associated with the rotation of supermassive objects. Physicists have predicted phenomena occurring in the vicinity of black holes called closed time-like curves. In this scenario, the destiny of a material particle, a particle of matter in space-time, is closed, meaning it can return to its temporal starting point. Closed time-like curves. The possibility of such an event was confirmed in 1949 by Kurt Gödel, who discovered a solution to the equations of general relativity known as the Gödel metric, an exact solution of the Einstein field equation that allowed for the existence of closed time-like curves. Since then, other possible solutions to general relativity equations containing closed time-like curves have been found that imply at least the theoretical possibility of travel in time, backward in time. These are some of the physicists who have worked on this problem and published the data. So, the message that I received from the astronomy blog in 2009 implied that if I were to send a radar signal that would transit the ergosphere of a rapidly spinning black hole, it might be detected sometime in the past or future, or from the point of view of an observer, perhaps even before such a message was actually transmitted. According to some general relativists, if an object were to pass through the center at an appropriate angle of incidence, the object might in effect pop out into a remote region of space-time within our universe, past, present, or future, into another universe, or perhaps into some sort of parallel universe. So my response to this was to compose a message I called Swan Song to be transmitted to a black hole in the constellation Cygnus, one of the most studied astronomical objects in its class. Cygnus is a summer constellation visible throughout the northern hemisphere, and Cygnus X1 is part of a binary system about 6,070 light years from the sun. The primary star in the system is a magnitude 9.0 massive blue supergiant. And the black hole sucks off the Cygnus X1 is part of this binary system, and it absorbs, it takes mass from the supergiant, from the blue supergiant, which accounts for its spin rate. So unlike elaborately encrypted interstellar messages for extraterrestrials, Swan Song is an interstellar message for human beings, and as such, it's composed as an English language message in International Morse code. The body of the message refers to all preventable deaths from genocides, terrible accidents, catastrophic natural disasters, disease, including a partial sequence of the HIV virus, that put together have cost many millions of human lives. Swan Song lists these calamities beginning in 1935 for good reason, as we shall see. And this is the message content. Yes, it's a very dark message. It was really hard to write it. You know, I only had 1 hour's time to write it. I mean, the whole thing had to be transmitted within an hour for reasons that we'll explain, but it was like editing human lives. There's the HIV sequence. In the end, we wrote this paragraph. We acknowledge that, like the universe around us, we are both violent and peaceful in nature. it's precisely from this recognition that we derive our humanity. It does little good to apologize for past atrocities. Instead, we are driven to evolve into more conscientious beings capable of the promise and aspirations that also underlie the history of our experience. This may indeed be the last song. So you have to have radar to receive this message. Granted, it may be astronomically unlikely that such a message would ever be successfully received, but if it were, the receiver will have to have detected it with radar, which wasn't invented until 1935. The first radio telescope was created in 1931 by Karl Jansky, and the first radar was Robert Watson Watt, February 1935, and his colleague Arnold Wilkins. By the beginning of 1936, aircraft detection distance was 62 miles. By 1937, the first 3 stations were ready and the associated system was put to the test. So long as the swan song message was shifted a sufficient span of time in the past, it doesn't matter that a light speed message to Cygnus would take 6,000 years to arrive and another 6,000 years to return. If successful, the swan song message would, if I'm having a tense problem here, be received long before the message was actually transmitted in any case. And there's some other strange twists to this story. Fast radio bursts. The first of these bright, brief events was announced in 2007. They're radio waves that are polarized in a way that suggests they had been transited near extremely dense objects or near objects with extremely powerful magnetic fields. The brevity of these bursts means their source has to be small, hundreds of kilometers across at most, so they can't be from ordinary stars. Current theories imply that the radio bursts might be linked to very compact objects such as neutron stars or black holes, and they all fit a pattern that doesn't match what we know about cosmic physics. To calculate how far the bursts have come, astronomers use a concept called dispersion measure. Electrons in space scatter and delay the radiation so that higher frequency waves make it across space faster than lower frequency waves. The more space the signal crosses, the bigger the difference or dispersion measure between the arrival time of high and low frequencies. I'm getting ahead of myself here. If taken at face value, these dispersion measurements would imply sources for the bursts at all regularly spaced in distances from Earth, billions of light years away. Of course, no one knows what sort of signature would be imparted to a signal traveling backward in time. Astronomers have proposed a range of exotic hypothetical explanations for these radio bursts, including the collisions of neutron stars and entirely theoretical entities, including extragalactic, extremely distant theoretical objects called blazars and magnetars. There are actually now more theories for these signals than there are observed signals. Some scientists say a more likely explanation that the fast radio bursts all come from somewhere much closer to home, from a group of objects within the Milky Way that naturally emit shorter frequency radio waves after higher frequency ones. Stranger still is the fact that the radio burst dispersion measures are all multiples of a single number, 187.5. No known natural process can explain this. Another very good question is just why do these fast radio bursts have such strong correlation to Earth's integer second? There's only a 5 in 10,000 probability that this lineup is happening by coincidence. So most tantalizing, if remote possibility, is that the source of these bursts might be a who and not a what. If none of the natural explanations pan out, an artificial source, human or non-human, must be considered. Occam's razor. So in 2010, I reapproached Arecibo Observatory to solicit transmission of the swan song. At that point, Arecibo was in a process of administrative transition and permission to transmit the message was declined. I also approached MIT's Haystack Observatory soliciting swan song transmission. These are both over 1 million watts. To transmit it from Millstone radar, where Poetica Vaginal was transmitted, but I was referred to the United States Air Force program directors at Vandenberg Air Force Base, who contracted the Westford, Massachusetts facility from MIT for space surveillance network activities. They responded with these official forms that assured me that some of their data could be shared, but not all of their data. Of course, I had not requested any of their data, and that interim use of Millstone radar's 3 megawatt transmitter would be out of the question. Some of their data, but not all of their data. I didn't want their data. I also approached Evpatoria radar in Ukraine. This was before the troubles there, and it was also unavailable owing to the diminished service lifetimes of the then irreplaceable components, huge klystron tubes critical to radar performance. At 70 meters, this Evpatoria radar is the second largest radio telescope in the world. So, in turn, I sent the message body to various, here intentionally unspecified astronomers worldwide. Though the coded message contained my own name, I suggested that the message could be transmitted anonymously without public publicity or fanfare, and that it could be carried out during the normal interval between experiments when radar apparatus are tested for various operational parameters. The swan song message length was intentionally configured to accommodate just such test intervals. In order to protect the privacy of collaborators, I also specified that it should not be necessary to notify me personally that the swan song message was actually transmitted. So, according to plan, I received no response or acknowledgement from astronomers for several weeks. Then a very strange message appeared in my mailbox from an astronomer at Cornell. It was a book by this guy, H.G. Wells, published in 1937, called Star Begotten and Biological Fantasia, dedicated to H.G. Wells' friend, Winston Spencer Churchill. The book is about, I'm an avid science fiction reader, and I had never heard of this book. The book is about Joe Дэвис and biological messages from space. Winston Churchill had radar in 1937, which is why a few years later on, England won the Battle of Britain in the air war against Germany, with Battle of Britain with 2,600 Luftwaffe planes to RAF 640. It was the use of radar that turned the tide. And strangely enough, Churchill has a newly discovered paper about alien life, thus far unreleased. It's in his archives in a museum somewhere in the Midwest, in Fulton, Missouri. All of this may be some sort of serendipitous coincidence, but maybe not. What all this means is that maybe, just maybe, we're all part of an alternate timeline. We've all heard about quite a few apocalyptic scenarios, extinction events raining down from heaven, suffocating menace we pour into our own atmosphere as a result of the human appetite for energy, the COVID virus and all of its changes, these stabilizing democracies, collapsing economies. It's the perfect storm. We live in a scary world, and there are a lot of bad dreams out there. And the scarier it gets, the more bad dreams seem to appear. But see, that's the problem. Returning to the legend of Pygmalion for a moment, we see that there is a form of transanimation we neglected to consider before. This is not a transformation of base metals or mythological beasts. This is a Pygmalion effect in social science and psychology that shows how we bring our beliefs to life. Our beliefs about others influence our actions, which in turn impact the beliefs of others about ourselves. These beliefs then lead to or cause the actions of others that in turn reinforce our beliefs about them. This process of self-fulfilling prophecy has been a topic of study, has been a topic of study in sociology, in psychology, and in philosophy. If we decide in advance that Friday the 13th is going to be a really bad day, it probably will be. The point is that since all of our dreams are going to come true, we're going to have to count on at least some of us to have a few good ones. And that's it. And I ran way over, sorry.
Yeah, that's absolutely okay. And we can take a few more minutes for questions. So I thought that was a beautiful note to end on, but maybe to end the talk on before turning to questions. So Natalia is with us, or maybe I'm asking questions. I can go ahead and begin. We saw a few questions from our audience, starting with Natalia's with us. So I'll let Natalia take over.
First of all, thank you for this talk, a very extended one and exciting one. And we have some questions, sure. So maybe we can just read them all. Peter, what do you think?
Yeah, sure. Well, I said there were some of them I thought kind of went together. There were a lot of questions about how to decode the responses from these SETI initiatives. Louise asked sort of what sort of message you hope to receive, but there were also questions about how to go about finding those answers. So CH9 asks, has there been any organized effort to find messages inserted into DNA from previous intelligences? So was there already were people already seeking that kind of answer or that kind of signal in DNA?
The CEO of the SETI Institute, Bill Diamond, has made me a kind of de facto consultant. And I think that, I mean, this is a really complicated question. And I think that it will be addressed within a short period, reasonable period of time, and that it will involve experts in many fields, including biology, biochemistry, astronomy, philosophy, hopefully art. No, there have not been any concerted efforts. Once, back in the 80s, Dana Boyd and I searched the then database of all DNA that had been sequenced for prime number factors, and we found all these images. We recreated the images. We found all these images. Some look like double helices. Dana thought some looked like aliens, but Of course, all of that was probably coincidence. And by the way, we managed to shut down, it was like 1986 or something, we managed to shut down Harvard's computers because we found so many. The computer system crashed overnight. Oh no.
There was also the question of Louise, if I'm reading your question right, what message would you like to receive? I guess that's a question about what you would hope for. I don't know if that means about the content or just that you would hope for anything at all.
You know, whenever you look out, the farthest reaches, at the edge of the cosmos, you're going to find your own cerebral cortex imprinted there. And when you look within, you always find the other. The thing is that that's the real quest. The quest is to be able to answer these questions in the first place. Is this what we know? Is this who we are? Because without answering those questions, we have no hope of communicating with any other entity. I mean, yes, all of these messages, they're messages for ourselves. Far more importantly than they're messages for anyone else.
Natalia, next question to ask here, since we have a few.
Well, I actually would pick one of my questions, if
yes, please.
you let me. Joe, how was it developing for you? Like you're both related to scientific community in a way and the artistic one. So where do you feel more related? Where do you feel maybe more comfortable? Or what is the way to combine this different approaches? And is this thinking at all different for you? Or this is from the beginning, from the very beginning? Yeah.
I think we were designed to do everything, and that it's only an artifact of culture that like slices us into, puts these into these little avenues of practice that it's the outside force to say this is your avenue of practice and this is what it entails. But see, human brains are kind of universal to begin with. I don't think there's any reason why an artist should not be as absolutely rigorous and precise about his or her practice than anyone else, than any other discipline. And I think that now more than ever, you know, the future of art and culture depend on, and science depend on a very increasingly multidisciplinary base that we have to be able to, like, you have to be able to read. We have to have scientific and aesthetic literacy. We can't deal without either one.
Thank you. Peter, do we have other questions?
Yeah, there were other questions. Actually, I was hoping that whoever is sharing at the museum, we have an enormous white rectangle on the screen. So if they just somehow can switch to, if that's you, to speaker view, but it may be on the museum's computer, we may not be able to fix it.
No,
really?
I can't.
Or if you can, Joe, I think you're still sharing your
maybe if you stop screen sharing, then we have it.
Hold on. If I switch it off?
Yeah, you don't have to share your screen anymore.
The screen sharing, yeah.
See how can I do that?
It's at the bottom toolbar there's something that says share screen, and there should be a button somewhere that says stop sharing.
Yeah, but I don't have that screen in front of me. Oh, here we go, maybe. Nope, I don't have that screen in front of me anymore. It's resume share. I'm already stopped sharing.
Oh, that's weird. So it's something had somewhere else in the,
Oh, yeah.
oh wait, something happened.
I did that.
Okay.
Yes.
I fixed it. Good.
Good.
We had another question about, Igor asks, what do you think about the theory of universe simulation? So actually, I guess they're asking if there's the possibility that the answer to SETI may determine whether or not we're living in a simulation. I think, if I'm understanding Igor's question
The
correctly.
Matrix.
Yes, the Matrix question.
Well, that's pretty far out. If it's a simulation, whoever's doing it is pretty damn good. No. It's funny, what comes to mind is something from Quran. So,
Something too grand.
no, something from Quran.
Ah, Quran, yeah.
And maybe it's not from Quran, maybe it's just from the commentaries, but it's something that's so God visits Muhammad and he says, here, Muhammad, here's this glass of delicious yogurt. If you drink it all Muslims will go to heaven. And so Muhammad takes the glass and he tastes it, and damn, it is the best, most delicious, celestial, divine yogurt. And he drinks half the glass and puts it on the table. So whatever we were given, you know, this is what we have to work with. Like I said, I'm an avid science fiction reader, and you know, this simulation would have to be so incredibly perfect, like down to the level of, you know, like the weakly interacting massive particles, down to the subatomic scale, to the vast astronomical scale. I think such a simulation, if it were a simulation, it would have to amount to like divine intervention or something. It would be inextricable. It would be inseparable from something that we would normally classify as divinity if it was a simulation. That's just my take on it.
So I guess we'll count that as it's the sort of it's all real answer on some level.
Yeah, I'm a kind of rational guy.
Yeah. Any other questions from you, Natalia?
I think there is a good question from Sappho Poeta about the research and its development. So have you had open doors in the institutions since the beginning? And how did you do your research in terms of finding?
No, the doors weren't open. I mean, it was always like when I first arrived at MIT, they called the cops. When I was first started working in biology laboratories and other laboratories at MIT, they were going, well, what the hell does he think he's doing? Nobody understood. You know, like it takes, for some reason, it always takes like 20 years. And then they say, did he really say that? Like, when I created Microvenus, my colleagues said, "Oh, well, this is maybe scientifically interesting, but it's certainly not scientifically relevant." And now there's over 500 citations in the scientific literature. It just takes time. You can't just go knock on the laboratory's door and not do your homework. When you ask a question, you have to postulate the solution. You know, it's not like not how can I move the mountain? It's like, if I do this and this and this, do you think I can move the mountain? That's a better way to frame the question. I mean, they'll come to the laboratory door with their clipboards and their lab coats and go, "Excuse me, I'm saving the world right now. What is it that you want?" You know, you learn to find other avenues to approach science. Like MIT is really good, has been really good because it's a kind of big social community with all these different disciplines and all these different languages, different points of view. I would often find my collaborators at the Muddy Charles on Friday afternoons. The Muddy Charles is the MIT bar, where you hear all these, you know, all these stuff going in all these different directions of people trying to explain, you know, one thing to another, one discipline to another discipline, and all this synthesis going on. That was like, I think, a big part of my education. Yeah, I mean, yeah, I wasn't paid for nearly 40 years. And they would say, "Well, how the hell do you do this? Why don't you go get a job?" You know, like, but I have a job, and I had courage. I knew that it was important. And I suffered the consequences. That's where the courage comes in.
We also have one question from Postscriptum asking what you think of biohacking as an art form of the future.
And the past, those qualities of vitality and function that distinguish life and death. Art history is perforated with these ideas and these concepts about all the forces of nature. It's like you know, it's a kind of the Enlightenment ideal that we don't surrender ourselves to the divine hand or the natural disaster. We're not hopeless victims of all this stuff that we do have. And we have the resources to confront all this stuff. You know, you think the world should be a reasonable and rational place and proceed according to certain rules, but it doesn't. And that's probably where all our problems come from. We expect everything to be reasonable and rational to that, and it isn't. And then you like get frustrated and freak out. Well, I think that when everything's going just right, then we need to worry. It's like, that's the problem time.
See, so by that measure, does that mean you're not worried at all? Things seem to not be going right. Does that make you more free of worry?
Well, you know, I'm in my element. it's the kind of world I place myself in on purpose. You know, I feel like I'm not really not an extraordinary human being. From my own point of view, I'm a normal human being with normal abilities. It's just that somehow I've managed to keep my eyes open. Yeah, I have a lot of problems right now, suddenly. Strange. I had a dream I was being burned at the stake. A few days before the fire just impacted my apartment building, and I was evacuated from my apartment for some 3.5 weeks. And all this terrible labor went on. But anyway, I had this dream a few days before the fire that I was being burned at the stake, and it woke me up in the middle of the night. And it's funny, they were my friends. I was burned at the stake in an auditorium full of people that were like sympathetic, and they were going, "Joe, you know you have to do this." And I was trying to hide behind the door. It didn't work. Arm on my shoulder, they brought me to the plinth and lit the fire, and the flames came up. And then I woke up, and whoa, it was the middle of the night. And a few days later, I woke up and I could hardly breathe from the smoke, and the firemen were pounding on the door. Get out now. Yeah.
So this all happened in a few days before your building caught fire.
Yeah.
Wow.
Yeah, but when the firemen were pounding on the door going, get out now, and that wasn't a dream.
Yeah, yeah.
Or it was a very elaborate simulation. Yeah, now I have, all this stuff about the fire. I had to evacuate everything from my apartment, and it was like a terrible labor in the heat wave. And a week after the fire, I was diagnosed with bladder cancer in this terrible, excruciatingly painful procedure, and told that my series of surgeries was imminent, and that I'd be going through all of this again, and that I'd be doing chemo. But like I said, I'm in my element.
Thank you for sharing this. I mean, it's very, I don't know, it's very deep for me to hear about all of this. And in fact, to be part of that, the whole situation, and also have some thoughts about own life and other people.
Yeah.
So that's, I just really hope that we're gonna see you, and that the further invitations to the festivals and other projects, they will be still doable and workable. So
don't forget, Sarah Khan and I are making a lot of angels. We're going to change the whole demographic of heaven. Hopefully there won't be any synthesis errors, right? We make the right kind of angels. Thank you very much. It has been my pleasure. And I feel it is a great honor to participate in this, in the Museum of Cosmonautics. To me, that's a great honor. And thank you very much for inviting me. And the best to everyone. So I'll cut out now. Yep.
Thank you.
Thanks so much, Joe.
Bye.
Bye-bye.